An exponent is simply a notation to indicate how many times the base is multiplied by itself. Here, my base is x, the exponent is 3, so my base is multiplied 3 times. X times x times x. Here my base is 1, my exponent is 1, so this is the same thing as writing x. If you ever see a variable without any kind of exponent, there is an invisible 1. When you see an exponent of 0, anything raised to the power of 0 is simply 1. When you have the same base being multiplied together, we can expand this to be x squared is expanded to x times x. X cubed is x multiplied together 3 times. Now, when I count up how many times x is being multiplied together, I can use an exponent to show that it is 5 times multiplied. 1, 2, 3, 4, 5 with an exponent of 5. As you practice these problems, take a look at the exponents of my same base being multiplied together and compare that to the exponent of the answer. Do you see a shortcut? Now what if I have a base raised to an exponent that is then raised to another exponent, an exponent raised to a power of 2? Well, this power of 2 means take the base and multiply it by itself. Here my base is x to the 3rd power. So I'm going to take x to the 3rd power, I'm going to multiply that by x to the 3rd power. I've expanded the square. Now I'm going to expand the cube. I'm going to write the cube out long ways. X to the 3rd means x, x, x. 3 x's multiplied together. The next x to the 3rd is another 3 x's multiplied by each other. I'm now going to count how many times x is multiplied together, and I see that it is multiplied together 6 times, so I can write this as x to the 6th. Once again, please compare the exponents in the original problem to the exponent of our final answer. Do you see a shortcut? We continue working. Now we have a fraction with the same base being raised to a power in the numerator and in the denominator. Well, I'm going to expand my numerator. X to the 5th is x multiplied by itself 5 times. 1, 2, 3, 4, 5. I'm going to expand my denominator. X to the 3rd is x multiplied by itself 3 times. Now when I look, if I have anything divided by itself, x divided by x, that cancels out to 1. I get to cancel the common factors in the numerator and the denominator. I have 3 common factors in the numerator and denominator. So the only thing I'm left with is x times x in my numerator. So my answer is x times x, which is the same thing as x squared. We have the same base, and we're using division. Now look at the pattern. Can you find a shortcut? Now I've got x to the 3rd divided by x to the 5th. My numerator is going to be x multiplied 3 times. My denominator is going to be x multiplied 5 times. I see that I have common factors in the numerator and the denominator, so I can cancel those to 1. This leaves me with x times x in the denominator. Remember, we canceled to 1, so my numerator is simply 1. My denominator is x times x, and x times x is simply x squared. Now, look at the exponent of the original problem. We are dividing the same base. Now look at the exponent and its location in the final answer. I'm going to give you a hint. Another way of writing 1 over x squared is x to the negative 2nd power. If you have x to the 2nd power in the denominator, if you want to write it outside of the denominator, up in the numerator, you make a negative exponent. Good luck on the practice problems.